Hello, today I have this tutorial for you on factoring. And so our first job is to factor 2x squared minus x minus 6. And there's 6. And there's many ways to factor such a thing. If you know an area formula, that's the way we're going to go about it. There's another way. I know Emmanuel teaches a different way. They call it George. We're just going to use an area formulation. So, without further ado, when I do this formulation, the first thing I do is make a diamond. Now, with my diamond, and I know it looks like an X, but it's supposed to be a diamond, if you remember from when you've seen these things before. When I make this diamond, my number on top is always the leading coefficient, the one by the x squared in front, times the negative 6, and I get negative 12. So that would go on my diamond. The number that goes on the bottom is always the number by the x. So that would be a negative 1. So now I need to find something that multiplies to negative 12 and adds to negative 1. So I'm thinking maybe 3 and 4. And I think if we add, we want that 4 to be negative. So 3 times negative 4 is negative 12. 3 plus negative 4 is negative 1. There you go. If the diamond works, then this expression should be able to be factored. So now I'm going to go to my area model. This is called a generic rectangle, the box. And in this generic rectangle, I can fill in the areas of each piece. This first piece up here has an area of 2x squared. The bottom piece down here has an area of negative 6. Now to know the areas of what goes in these other two rectangles here, that's what comes from the diamond. I have the 3 and negative 4. So I'm going to go 3x and negative 4x. There's all the areas. And if I had algebra tiles, we could build something like this so we could factor. Now I go about this as the greatest common factor. The biggest number I could divide out of both these. And the biggest number I can divide out of 2 and 3 is just 1 evenly. There's an x and an x squared. So the biggest thing I could divide out of there or pull out of there would just be an x. Greatest common factor right there. The greatest common factor across the bottom. So the biggest number I could divide out of both those, it looks like, is a 2. Now they don't both have an x, so I can't divide an x out of both of them. They are both negative, so I would think that my greatest common factor would be negative 2. And it is. So x times what would go up here should give me 2x squared. So x times 2x. X times what up here would give me 3x. So x times 3. Negative 2 times 2x is negative 4x. Negative 2 times 3 is negative 6. So I think this symbol right there should be a plus. And this symbol on this other side is a minus, which we already have. So our factors are x minus 2 and 2x plus 3. And if we multiplied them out, we'd get the same thing as we have in the box. There's the factors. So let's try this again. Now this one here is called the difference of two squares. The word difference means subtraction. So I'm going to abbreviate difference and put a minus sign by it. Squares, well, squares are when you square something, times it by itself. So x times x is x squared, and 7 times 7 is 49. 49 is a square number because it's made by 7 times 7. X squared is x times x, so that's also squared. I want to factor this. Now we can factor it the same way. So the first time we factor this, let's go ahead and factor it the same way. So whenever I factor it, I would take the first term right here, the leading coefficient by the x squared, and times it by the last term, which is the number, and I get negative 49. Down below is always the number by the x, not the x squared, the x. I don't have an x, so what could only be the number in front of it but 0. So I have 0 x's, no x's. So what multiplies to give me negative 49 and adds to give me 0? Well, I know 7 times 7 is 49. And if one of them was negative, well, negative 7 times 7. And negative 7 plus 7 is 0. So there we go. And you can also do the generic rectangle, the box. And when I fill this in, the area of my first rectangle is x squared The area of my last rectangle is negative 49. Interesting area, huh? And then 7x and negative 7x. Greatest common factor, well, for the numbers 1 and 7, I just get a 1. And they both have an x, so 1x. Greatest common factor on this one down here looks like 7. And since they're both negative, I'm going to go with a negative 7. X times x gives me x squared. X times what gives me 7x? Well, 7. Negative 7 times x is negative 7x. Negative 7 times 7 is negative 49, so this has got to be a plus. So my factors are x minus 7 and x plus 7. Now this is a difference of two squares, and you see the factors we got there? It turns out when you take something, and I'm going to put this into a formula style, a squared minus b squared. Every time you factor something like that, the first thing you will always get is a minus b. Well, maybe that's not the first. They can be in any order, but you will get an a minus b factor, and the other factor would be a plus b. So those are always the factors you get when you have the difference of two squares. So, for example, I don't have to go through the whole process if I remember this idea. So I have, say, x squared minus 16. So the factors for that would be x minus, well, this is squared. This is a difference of two squares because 16 is just 4 times 4, right? So x minus 4, x plus 4. And then I could try this again with another problem. I could go x squared minus, I don't know, maybe minus 100. Is that a difference of two squares? Yeah. X minus 10, x plus 10. And let's take it just one more step. One more step. And this one will be a little different. What if I had 9x squared minus 25? Now, if I had to multiply 9 times 25 and build a diamond with this, the numbers would be huge. It's not impossible. The numbers would just be pretty big. But if I realize that this is the difference of two squares, then what squared gave me 9x squared? What times itself gave me 9x squared? Well, 3 times 3 is 9, so isn't it just 3x? And what times itself gives me 25? Wasn't it just 5? So 3x minus 5 and 3x plus 5. Difference of two squares. When I see a difference of two squares, I love doing those. Okay, last but not least. I haven't done this before on any of these problems, but this is always the first thing I look for. So, number 1, GCF. This means greatest common factor. The biggest number I can divide out of every number that's in this expression. So I have 12x squared plus 26x minus 10. 12, well, that's divisible by 2. 10 is divisible by 2. 26 is divisible by 2. Let's take out a 2. So I'm going to divide everything by 2, but it's a factor, so I can't make it disappear. So I take my 2 outside. 2 times what gives me 6 or 12x squared, which is 6x squared. And then 2 times 13x gives me 26x, and 2 times negative 5 gives me 10. Now my goal is just to factor what's left. So I'm only looking at what's in the parentheses. I've taken out the 2. And the reason I took out the 2 is the numbers are smaller. And it's so much easier, for me anyway, to deal with smaller numbers. Because the bigger the numbers, the more possibility, the harder it is sometimes to come up with what you need. So I go to my diamond, and the top of my diamond goes 6 times this negative 5, so negative 30. And then the bottom of my diamond goes 13. So what multiplies to 30 and adds to 13? Well, negative 30 actually. Well, I'm thinking 3 and 10. So let me put that up there. And these aren't going to work, but let's try it. 3 and 10. That does multiply to give me 30. I could make it negative by making -3, but I can't add them to get 13. So that's not working out. 3 and 10. So maybe 2 and 15. Well, 2 times 15 is 30, not -30 though. And I need a positive 13. Well, let's just make that 2 negative. -30, 15 minus 2, 13. There we go. We got it. So then over here to my generic rectangle. So remember, this is an area. So let's see. Where would I put in this first box? Well, all I'm looking at is trying to factor what's left here. So I would put a 6x squared in there. And since this is what's left here, I have -5. And along this diagonal here, I use my diamond, -2x and 15x. And one thing I didn't show you before, but you should notice, is this the 6x squared and this 6x squared are exactly the same thing. 15x minus 2x is 13x. Exact same thing as what we have there. And this -5 and that -5 are exact same thing. What is inside this box is the same thing that we have up here. Now, same thing. We want to take out the greatest common factor. So -2, 6. The greatest common factor would be 2 as far as the numbers go. And they both have an x, so 2x. Greatest common factor here would be a 5. And they're not both negative, so I'm just going to leave it at 5. And they don't both have an x, so that's all I got. 2x times what gives me 6x squared? So I'm looking at 3x. 2x times what gives me a -2x? -1, I think. 5 times 3x is 15x. 5 times -1 is -5. So this must have a plus sign in between. So my factors here are 3x minus 1 and 2x plus 5. That's all I got for you today. Good luck. Thanks for watching.